So hello, welcome to this video tutorial. I'm going to talk about 3D printer, especially one technique that we call vase mold. I'm going to show you here some examples. All the objects that I'm going to show you, they have something in common. They were printed in a vase mold. Okay, all of them. So we developed it with some technique through Rhino, grasshopper, and Cura that allow us to generate some uh, really fast 3D printed objects. And then we are focusing right now in lamps. Okay, so here what is important in this case is that we have a socket, okay, that we need to put inside like this. It's a prototype to check if the size the hole is right or wrong. Here we have another prototype. So, but what is important is that we are printing in vase mode. And then we can get this type of a shape also with some apertures, okay? And then finally, I'm going to focus in this lamp, okay? So I'm going to show you how we model this through Rhino, Grasshopper, and then how we export this in a STL file, how we can open the file in Cura, and then how can we get the G-code through Cura to the 3D printer, in our case, the FedEx printer. Okay, so I hope that you enjoy, and let me know your comments about if you have some doubts. This will be really welcome. Thank you. So what we have here is the lamp holder. Yes. Okay, like I showed you before. So this is the something important if you are going to design your lamp. Another important aspect here is your maximum size, okay? Otherwise your lamp is too big and you cannot print. What we develop here is this shape, okay? So let me hide my maximum envelope. I'm going to send you also the file, okay? And what you have here is just, let me turn off the lamp holder. Okay, so what we have here is a combination between some surfaces that are this one. This is one surface, okay, and then here we have the base. That is, in this case, is a solid. Okay, and what is important with this technique is that you need to control the thickness that you have here. Let's check the distance from this point to this point. So my thickness is 1 millimeter. Is enough to get your really strong base. Okay, like one. Also, this one is 1 millimeter. Okay? Of course, could be 2, could be 3, but we are trying to use the minimum quantity of material. So here we have this is let's say the idea is to have surfaces and also solids, okay? Let me open the grasshopper. Also, I'm going to send you the grasshopper definition that allow us to generate some twist in our lamp, okay? So I'm going to put here, let's say 45 or whatever degrees, and let me select all my definition in order to show you, okay? And then I'm going to select my surface in Rhino, and then I'm going to hide, okay? And also I'm going to hide here the original shape. This one. So this is the shape that you are going to print. Okay? So what is important here in order to get the shape in Rhino, because this is a grasshopper object, is that you need to right click and then you need to bake. Okay, so something that I suggest you is to before generate one layer. Let's say, I think baked layer is here. So I'm going to bake this to a specific layer. So I know where is the geometry, and then I can hide all my grasshopper definition. So now I have something. The object, my lamp, is belongs to Rhino. Okay, and then I'm going to select both. I mean the surface, that the lamp surface and the base, and I'm going to export both at the same time like a STL file. And then let's put here lamp. I'm calling this pyramid lamp. Okay? And what also is important here, that the tolerance that I recommend you to work is 0.01. So I get a really nice definition. Okay. Of course, you can play with this value if you want. So now we need to export also open objects because my surface is an open object. And then we have the file. Okay, so now I'm going to Cura. Let's go to Cura. I'm using the Cura version 4.11, but it could be any other version. So I'm going also to provide you some presets, some profile that can help you to go directly to Cura to load this profile, and then you just apply your geometry, and then you get your G code. Okay, so the idea, of course, I recommend you to explore the Cura if you have time. Explore the Cura so you can get some new geometries there. You can play also with the Cura, like I showed you before. This type of example, just apply the fuzzy that is inside Cura. Okay. So let's see how to do that in Cura. So, okay, so now we are here in Cura. I'm going to provide you the preset or the profile. You just need to come here in Manager Profiles, and then you are going to import the profile that I send you. Okay? Just this. You import the profile. Great. And now I'm going to load the part, my lamp. Open the file. Is the STL file that we created before. So if you see that your lamp is outside your box, just select the object and move and put here at the center. Also, if it's upside down, I need to rotate the object. I rotate here in this axis. Okay. And then also in this case, I need to rotate a little bit here. So now I have my shape totally inside my envelope. Okay. Once you have this your object in the right place, you can submit this to the slice. Let's highlight some aspects here. The line height is 0.5. My line width is 0.7. This is included in the profile that I'm sending you. Okay, just check some basic information here. And then what is important here to highlight is that in special modes, the surface mode is activated, the Spiralize or the contour. This is important in this technique. So we slice, and then we get the information. There is 2 hours and 4 minutes to print the lamp. It's fast enough. Here we check the layers to check if everything is under control. I see here my first layer, and then I can go to the second layer, and so on. And then let's see here our bridge. We call the bridge. This is my bridge. Can you see this layer here? The next one, maybe? Yes. So this line is printing in the air. Okay. Since our distance from this point to this point is 2 centimeters, I mean 20 millimeters, This is not a problem. Okay, and then we save this to the disk. Let's put here the name would be 3, and then I generate here my G code. Let's open the G code. You don't need to do that, but with a notepad, and I see here my G code that I'm going to send to the machine. Okay? I see here all the G1s, because the G code for 3-bit is just lines. So G1, X and Y, G1. So you see here a lot of lines that represent all the movements that the printer needs to do. Okay, you don't need to open this file, but for curious, it's interesting. And then you just send to the machine.